All right, we're back in the studio for using scientific measurements.
Actually, you're going to learn more about our periodic table that we made. Let me rephrase that. Periodic pie. She did pie, by the way.
It is very good pie. Pie, pie, pie. Pie, 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 pie. Pie, pie, pie.
Pyrella. Mr. Pyrella.
To be more creative, we decided to do a rap on cereals. We got the Cheerios charms, cookies in the checks, puppies to the loopies, to the crispies, to the Wheaties, nutties, crunchies, berries, minis, flakies, to the kicks on Krispies. But don't forget the brand. Oh man.
That didn't work. No.
Since the rap didn't work out, to be a little more creative, we decided to make a love poem.
You're the raisin to my bran, the rice to my checks, the corn to my flakes, but you're the lucky to my charm. But you're always the honey to my nut. Oh my gosh, thanks. The cocoa to my puffs, and the crunch to my nuts. So sad. But your nuts are always golden.
Okay, stop. That sounds like crap. Third time's the charm with our introduction to this video, so we're going to try a soap opera now for our creativity. Lucky, we can't be together. We're from two different quadrants. You from the multicolored and I from the brown.
I know we can make this work.
But you could get in trouble.
Nothing will stand in my way.
Mr. Flake?
I saw you, Lucky. I saw you in the same bowl as my wife last night.
Yeah.
Now, after all that, we decided to take an easier way here and just to describe our table. Now, the regular periodic table is a square, but we took from what we knew from the unit and we decided to change it and show what we learned by making it a circular diagram.
This diagram was divided into 4 quadrants based on what color each cereal was. So there was a tan, cream, brown, and multicolored quadrant.
Each cereal within that quadrant radiates outward to the lowest calorie number. Each shape was color-coded differently. Blue is circle, green was square, and purple is abstract.
In the regular periodic table, each element was organized by things like atomic mass, atomic number, valence electrons, whether they were metals, nonmetals, or metalloids. Ella, you can knock it off. But in this case with the cereals, we decided to organize them a different way with different information like.
What we did to organize where the cereals went exactly is we divided them up with their shape, their color, their flavor, the sugar, calories, fiber, and carbs. Now, not all of that came into play and made sense when we figured out where everything went, such as the fiber and the carbs didn't have any pattern or effect on where we placed each cereal.
And we just decided to do those because instead of having 5 properties, we wanted an A. So we did a couple more, just for you.
Well, it was finding the information for each cereal, such as the nutritional information and its shape.
Yep.
Their properties. Isn't that good enough?
Yep, that's good. The biggest challenge that we faced was how to organize everything and make it coordinate into a pattern, especially since we did a circle diagram instead of a square one. We kind of had to go from scratch. We didn't really know how to do anything really. So it was basically making sure that everything radiated out correctly and how it was supposed to.
It didn't have a specific spot, so we had to make it. Some of the strengths of our organization was pretty simple. What we did after we found out the color of each cereal, and we had the quadrants, and finding the nutrition value of the sugar and calories, because those went together. If you found the highest calories, it's going to pretty much have the highest sugar. So once we placed the first one, all we did was decrease them and radiate them out through the calories pretty much. And the fiber and the carbs just kind of played another role into it.
Another reason why I think this is a strength is because it showcases our knowledge about this much more, because who else made a periodic table that is a circle?
No.
Just us. Yep. So, yeah. goes to show you that we are creative and we deserve an A for this project.
Because we worked hard.
Very
We did
hard.
work hard. This is like the most amazing video, and this is why we're trying to get in
And
there.
seriously, we've been here for like 3 hours now, so.
Yes.
4.
Yeah, pretty much almost.
Not 4, no.
Oh, okay, 4 hours,
Yeah,
yep.
4. Well, one weakness is that carbs and fiber do not follow the same sequence calories and sugar did.
So those basically had no part in what we did at all. They were just there.
Yeah, just there for your knowledge. And another weakness is that each color just kind of relates and compares with its own color. So the cereal multicolored isn't comparing with the color in tan or cream or brown. So that's another weakness, unlike non-metals, metals, and metalloids in a periodic table where they all can be related. In ours, only the same ones in the same color can be related to each other.
You know, we really struggled with this last question because we couldn't quite figure out how else we could have done this project.
How we could have taken it to a different level, a different approach at
Maybe make it into a diamond?
star? I don't know. I mean,
Maybe a horse.
that could
That
work.
could work,
That
you know?
could work. We could do that.
Definitely not a rectangle.
No, rectangle.
Yeah, that's like out of the question.
No.
Who does that? No,
Yeah.
no way.
Wait,
Freaking rectangle.
Unfortunately, our conclusion isn't as creative as our introduction, so we're just going to leave it at that. Thank you for listening. Hope you enjoyed it, and we'd love to get an A on this.
Do you want to see a magic trick?